So the first chapter, the first section of chapter 9 is work equals force times distance, and you use the equation to calculate work when force is constant and motion takes place in a straight line in the direction of a force. Two general categories are work done against another force and work done to change the speed of an object. And the unit of work is the joule.
For section 2 of chapter 9, we have power, and power is the rate at which work is done. The equation is work done divided by the time interval, and then the unit power is the watt, which is equivalent to 1 megawatt, and it equals 1 million watts.
So section 3 of chapter 9 is mechanical energy, and the property of an object or system that enables it to do work. An SI unit equals joule. It is energy due to position or movement, and it is two forms of mechanical energy is kinetic and potential energy.
Section 4 of chapter 9 is potential energy, and the definition is the amount of gravitational potential energy possessed by an elevated object is equal to the work done against gravity. There are two different ways to calculate gravitational potential energy, and one of them is weight times height, while the other is mass times acceleration due to the gravity and multiplied by height.
Okay, so section 5 of chapter 9 is kinetic energy, and it's the energy of motion, and the formula is Ke equals 1/2 mv squared, and kinetic energy equals the net force on an object multiplied by the distance the object moves.
Section 6 in chapter 9 is work energy theorem, and the definition is whenever work is done, energy changes. The formula is work equals change in kinetic energy. When it comes to the work energy theorem, there are 3 different forms of kinetic energy, which is heat, sound, and electricity. Heat results from random molecular motion, while sound consists of molecules vibrating in rhythmic patterns, and electricity is produced by electrons in motion.
Okay, chapter 9, section 7 is conservation of energy, and it's the law of conservation equals energy cannot be created or destroyed, and it can be transformed into radiant energy, and nuclear energy is transformed into heat. So section 9 is efficiency. A small fraction of input energy is converted into thermal energy. If the friction of an object against an inclined plane increases, the actual mechanical energy